everyone, welcome to the first video in my chemistry series. So today we're going to be talking about the metric system and dimensional analysis. So the metric system is going to be the system of units that you're going to use in every science really, so we're going to start off with that. So there's several types of base units for every kind of measurement you could want to make, but the three big ones that you're going to be using a lot in chemistry are the meter, the gram, and the liter. This is actually slightly misleading. I should add this is the kilogram. That is the base unit for mass. It's not actually the gram. That can be kind of confusing. So then we have prefixes that we apply to these base units in order to change the scale. So there's kilo, which is 1,000 times whatever your base unit amount is. So a kilogram is 1,000 times of the mass of a gram. And then we have centi, which is 1/100th of the amount of a base unit. Milli, which is 1/1000th. Micro, which is 10 to the -6th. And nano, which is 10 to the -9th. So this gives us a lot of different combinations of units that you could make, because you can apply any of these prefixes to any of the base units. But how do we convert in between these units? So you could always just multiply it by a factor of 100 or 1,000 or whatever the factor is, but there is a much more convenient way to do this, and that's called dimensional analysis. Because sometimes it can be quite confusing about, am I supposed to multiply or am I supposed to divide by this number? So dimensional analysis kind of eliminates that confusion. So the best way to show this is just with an example problem. So we're going to convert 27 cubic feet to cubic centimeters, given that 1 inch equals 2.54 centimeters. So you could always set this up just as a multiplication problem and just multiply or divide by the appropriate numbers. But in this case, you have cubic, so that means you're going to be doing everything 3 times. And you also have a conversion from standard to metric units, so that can be kind of confusing to keep track of all the numbers. So there is a more organized way to do this, and that is through dimensional analysis. So first, this is what you have, and this is what you want it in. So first you write down what you have. You have 27 cubic feet. And instead of writing cubic feet out with a cubed sign, I'm going to write feet, feet, and feet. And this is helpful because you can treat the units just like numbers. So a foot cubed is equal to a foot times a foot times a foot. That is the method that you use in dimensional analysis. You treat the units just like numbers, and your goal is to cancel out the units that you start out with and get to these units that you want to end up with. So you can only use multiplication. You cannot do addition or subtraction. So for example, if you're trying to convert between Celsius and Fahrenheit, you would not be able to do that through dimensional analysis because that involves addition and not just multiplication and division. So essentially what you're going to be doing here is multiplying by different forms of 1. So when you have something over itself, that's always equal to 1, right? So we're going to have equivalent forms of 1. So we're not actually changing this value, we're just changing the units. So let's get a form of 1. In order to cancel these 3 feet, we need to have 3 feet in the denominator in order to get rid of these 2, right? So we're going to have feet, feet, and feet. And since there's only 1 foot, we'll do 1 foot, 1 foot, and 1 foot. And here we have a conversion that's given to help us solve this problem, and it says 1 inch is equal to 2.54 centimeters. Except we don't have inches here, we have feet. But we do know that 12 inches equals a foot. And since we have a foot on the bottom, we can turn this into an equivalent form of 1 by putting inches in the top. So for every 1 foot, we want to have 12 inches. So 12 inches, 12 inches, and 12 inches. So now we have this fraction that we're multiplying by our original, and this is equal to 1 since every 1 foot is 12 inches. And now we have this, we can cancel out the feet. So our feet are gone, and now we have inches. but that's still not what we want. We want centimeters. And so that's where this conversion comes in. It says that 1 inch is equal to 2.54 centimeters. So we can multiply this by another equivalent form of 1. We want to get rid of the inches this time, so we go inches, inches, and inches, and each one of these inches is equal to 2.54 centimeters. So we have 2.54 centimeters, 2.54 centimeters, and 2.54 centimeters. So now that we have this, we see that we have inches in the bottom and inches in the top. So we can actually cancel out these inches. Not the number that's attached to the inches, just the inches. Because in dimensional analysis, we view the unit as being a separate thing from the number that's next to it, sort of like a variable. You can think of it like an algebraic variable. So you can cancel it out, you can multiply it, you can divide it independently of the number that it's attached to. So now you notice something that's kind of great. Here we have all of our units canceled out except 3 centimeters. So that means we are in centimeters cubed, cubic centimeters, which is what we wanted in the beginning of the problem. So now all we have to do to finish this conversion is multiply this out. So we multiply everything in the numerator and divide by everything in the denominator. And we end up getting this number. It's 764,555. And that is slightly rounded, so you might get a different answer, but this is how many cubic centimeters are in 27 cubic feet. And that is how you do dimensional analysis. Earlier in the video, I said that we can't use dimensional analysis to convert between different temperature scales. So here's why. These are the formulas for converting between Celsius and Fahrenheit and between degrees Kelvin and degrees Celsius. Oops, I made a mistake. We don't use the degree sign with Kelvin, we just use a K. So the reason that we can't use dimensional analysis is because both of these formulas involve addition and dimensional analysis is completely based around multiplication. So if you ever had to convert between 2 different temperature scales, unfortunately, you would have to just do it the hard way and just convert using the formulas. And you really don't, I don't think that you're going to need to remember this formulas because you're not really going to be using Fahrenheit. You may, however, have to convert between degrees Celsius and Kelvin in chemistry. So this 273.15 is a really important number to remember. So that's going to be the difference between 0 degrees Celsius and absolute 0. And sometimes people round it to 273, sometimes 273.5. That just depends on your class. But that is really all I have for this video, and I hope that you guys enjoyed it, and make sure to come back next time.